5块钱要挂全车。他们给你一刀啊，叫什么一刀？你 message 我啊？你看到？OK OK。
也那用的是第9个 edition 啊，
啊，
所以你有答案吗？没有睡眠的话，
你不是讲你有没？
我有第8吧，
一样的应该题目不是吗？
不是我刚找到第9了，你有啊？
要啊要。哎，喂，等一下，
有啊？
我有，上次不是跟你讲我有啊？
哎，你
有，
有啊？
但是我没有放出来。
你没有 send 出来给我们看吗？
是另外一个
你知道 Adam 是吗？
啊，
对，第9个你是有的，什么睡眠的？真的 send 出来，哎，有问题的话，看答案我不会的话，有时候
那怎样？你找到就找到啊，
有
不然其他人不要做了的，其他人等下不要做了。
有做了，
没有看个人，有些人会去做，有些人不会。有，对啊，好，知道。No mic, no mic, hello, no mic。No mic。没有麦。 啊，下雨天。对，Where's the other half of the class? Kevin Jim. Before we start, any question before I answer question from last week, last lecture? I mean. One Tian here or Guan Tian? Okay. Oh no, you asked me a question last time, right? Okay, I'm gonna answer later. Okay, thank you. Just checking the people who are asking is here. Yeah, maybe before we start, let's share some short news. So we learned about orbiting, right? The trajectory, I mean space curve, okay, can be used to calculate the orbit of planets. So what happens if a planet go, I mean, if moon go in between sun and the earth? What happens if moon go in between the earth and sun? Solar eclipse, right? Okay. So later, if you're lucky, you'll see solar eclipse around 10 to 2 p.m. I think. Today. Yeah, later. 10 to 2 p.m. If the rain stops, huh? I mean, yeah, if the rain stops, then maybe you can see it. If yeah, okay. Um, so before this solar eclipse, right? Do you feel very hot these few weeks? I mean, this week, right? Actually, there's a solar flame going on, solar storm. Okay, these few weeks. So finally, the moon come to the safe. Okay, so the moon, when they pass by, maybe will block some of the flare or storm. Yeah. Okay. So yeah. Okay, let's start the real business today. Okay. So I have one question on this r theta graph here. We want to plot it as a polar graph. I've been asked for this question a few times, so let's do it together. So typically when they give this r versus theta curve, okay, without giving you the equation, meaning maybe the equation is very hard to write it down. Okay, so they just give you the r over theta graph and then ask you to plot it. Okay, let's do the first one first. So polar graph, we need to draw it on a XY axis. So on XY axis, what are the 4 angles that you need to pay attention to? Are the 4 key angles you need to pay attention to? 0, pi over 2, pi, and 3 pi over 2. This is exactly plotted by this curve here. So 0, pi over 2, and pi, 3 pi over 2. Okay? All right. So let's look at the first quadrant, 0 to pi over 2. So at 0 degree, it is radius 0. Okay? So it's radius 0. So the first point is 0, 0. Okay? And then pi over 2 is also 0. I mean, let's pick a convention here, okay? Let's fix r theta, okay? The point, okay? Although we usually write theta r first, right? xy. Now we put r theta so that we can match to what we draw. So we also got 0 pi over 2, and then 0, 3 pi over 2, and then at pi, what do you get? What's the radius at pi? -2, okay. At 2 pi also 0. Okay, so you got 1, 2, 3, 4, 4-point meeting at 0. Okay. How about 1? Where is 1 here? Somewhere in between 0 and 2 pi over 2, and then not even pi over 4, right? Okay, from the graph. You guys see it? So if you split this interval into half maybe around here. A bit less than pi over 4. Okay. So maybe let's draw this quadrant first. So we split the quadrant into 4 parts. Okay, so if you want, we split it. I mean, maybe 3 parts is enough. Let's split in 3 parts first and then see. Okay, so from 0 to pi over 2. So the radius increases up to somewhere before pi over 4 and then decrease again when you meet, until you meet pi over 2. Okay, so let's draw this. So we start with 0, 0. Okay, so when the angle increase, so when the angle grow, the radius also grow. Okay, and then grow up to pi over 4, before pi over 4, and then it reduces. Okay, so let's join this curve together. So slowly you increase, before pi over 4, you decrease. Okay, and then come back to pi over 2. Okay, first quadrant. Does everyone follow? First quadrant. Okay. Okay, next. So what do you do next? Okay, maybe split to pi over pi first. So next is pi over 2 to pi, right? Pi over 2 to pi is the second quadrant. But what? The radius is negative. So you need to jump to the fourth quadrant. Okay, meaning when you do the jump, you take the positive radius. Okay. Does everyone follow? Okay. Because what? Because for example, -2 pi is equal to pi 0. 2, 0. Yeah, 2, 0. -2 pi is equal to 2, 0. Okay, so let's do it. So we start with 0 pi over 2, which is equal to 0, 3 pi over 2. Is it equal? Yeah. Okay, so we start from the fourth quadrant. So we start from the fourth quadrant, you increase up to 2. Okay, so when you meet 0, you reach the radius 2. In the meantime, if you have any question, you just point out. Okay. When you do it yourself, you think that this step you make a problem, then you should point out this problem. if I didn't address it. So we continue this when the degree increases. Degree increases, the radius keep increasing up to you meet 2. Radius 2. Okay? Radius 2. Any question? Yeah. Okay, no. So we keep continuing. So pi to 3 pi over 2. Okay? Pi to 3 pi over 2 is which quadrant? We repeat the process again. Pi to 3 pi over 2, which quadrant? Third quadrant, right? Okay. But the radius is negative. So you need to jump to the first quadrant, go to the opposite quadrant. Okay. And then your radius will go from 2 and then decreasing up to 0. Okay. So you decrease. So you decrease, slowly decrease up to 0. Okay. Okay, next, the last part. Last part is 3 pi over 2 to 2 pi. So which quadrant is this? Fourth quadrant. But the radius is positive. Right. So do you need to change quadrant? No. Okay, so you stay on the fourth quadrant and then you do the same thing. So what do I mean by same thing? So you start with 0 radius, increase up to 1, and then come back at 0, 2 pi. Okay. Okay. So maybe you can ask a question. Okay, you can ask a question. So why not this curve? Maybe somehow cut this, cut the small orbit. Okay. And maybe you can think about why this doesn't cut it. Okay. So when you mean by cutting it, right, that means they achieve the same radius at that point. Okay, they achieve the same radius at that point. Okay. So meaning there's some radius between 0 and 1, okay, achieved by the curve here. Right. First understand this first. If not, we cannot discuss. So if we want to cut this small, what do you call this? This small leaf here, okay? If you want to cut this small leaf here, you need to intersect the middle portion here with the small portion here, right? That means they must have the same radius at some point. Does it make sense or not? Okay, does it make sense? Everyone can follow? Can follow? Okay, okay. So they need to have the same radius, right? Okay, but not that one is positive, one is negative, right? Okay, so their relation must be differ by a pi, right? Must be differ by a pi, right? Because you see how you relate positive and negative radius. You take a difference of pi. Okay, can follow or not? Question, if you have question, ask. Can follow? Okay. Okay, so let's draw one line. So we cut it. Change another one. So I cut it here. Let's say I cut it here. Okay. So I want to see that if there's some negative radius that have the same point. Okay. So we identify this point, and this point. Example. Okay, for example. Right. But you can argue that you should be able to argue that because of the symmetry of this curve, right, they are not pi apart. Okay, so they won't intersect. Okay. I mean, this one is going to precise. This question actually is hard. Okay, this question is hard. So, and then there's another possible. I don't know why. Not sure why. Maybe you can explain to me. one of the attempt is going according to the weakness. They say you can draw as a fish. So how you draw like a fish? I don't know. Fish is the part I don't understand. Who draw as a fish last time? How you draw as a fish? Huh? Oh, you didn't flip. Oh, you didn't flip. Oh, yeah. Okay, then. Okay, then that makes sense. Okay. So if you didn't flip, then you become a fish. Okay. So if you flip, then this part will go here, and then this part will go here. Right. Yeah. So if you didn't flip, then you as a fish. This one didn't flip. Yeah. Any question? Okay. The rest can follow. How about this one? 32. When I saw this 31, I saw 32. So seems quite interesting. Any idea what's 32? Guess. Any guess what is 32 is? I mean, you can try draw on your paper. Okay, so let's talk about a bit. Hey, where's Jinghua? Uncomfortable. Oh. Okay, so you can see that this graph, right? Okay, slowly increase and then slowly decrease and then increase quite drastically here. Okay, creating a cusp. Okay, I think this point should be non-differentiable. Increase drastically again and then slowly decrease, so on. Okay, so similar method. Okay, so we split into 4 part or 3 part, up to you. Okay, so from 0 to pi, from pi 0 to 2 pi over 2. Okay, what happened? Okay, so it increases at a different rate until you reach 1. Okay. So you plot these 2 points first, 1 and pi over 2, and then 0, 0. Okay, so how do you increase? So you increase like this. Okay, when you reach 1, it's like slow, very slow. Okay, you started slow and then go fast and then end slow. Okay. Okay. So started slow and go fast and end slow. Something like that. Okay. And then what's next? Next is 0. So from pi over 2 to pi, okay, second quadrant. So you kind of stacked it at 1, and then suddenly you increase to 2. Okay. Stack it at 1. Suddenly you increase at 2 until you reach 2. You see, can I draw it nicer? Okay. Next part is if you want to use the symmetry of this curve, you can. Okay, you just reflect it. Otherwise, you can do the same analysis. So you decrease drastically at pi, around pi, and then you kind of static when you reach 3 pi over 2. So 3 pi over 2, you also reach 1. You have something like okay, and then you decrease again until you reach 0 to 2 pi. Okay. So you get a heart shape. Okay. Any question? Yeah. 31, yeah. Mm. Mm-hmm. Mm. Uh-huh. Pi to 3 pi over 2. Pi to 3 pi over 2. Let me think. You mean this one? You mean this one? You mean this one, is it? Okay. Yeah, I think you're right. Yeah. Yeah. But my point is, I think there won't be 2 pi across. I mean, there won't be 2 pi difference between this point. My claim. Yeah, right. Mm-hmm. Sorry. Yeah, you should find, yeah, if they intersect, there should be exactly pi difference. But my claim is these 3 points won't be pi difference from each other. Exactly pi difference. Yeah. This is my claim. Pi difference meaning because you see, is it? So is it? So how we equate negative radius with positive radius point? They are pi difference in the degree. Yeah. So my claim is these 3 points, there won't be exactly pi difference in their degree part. Yeah. Otherwise, they will intersect. Because they don't give exact number here, so maybe you can infer from the symmetry of this graph. Any question? No? Okay. Leave again. Okay. So before we jump into new topic, Anyone did this experiment last time I asked you to do? Try to integrate the reparametrized curve. Anyone did this? No? So if you try to integrate this reparametrized helix, okay, remember that last time we find some relation between S and T. Okay, what is S? Yeah, what is S? So S is the arc length. Okay, but this arc length depend on T. Okay. So yeah, I didn't really tell you what we are doing here last time, but I'm gonna show you using this experiment here. So if we go through this process here, okay, let's don't repeat what I said last time, this process. Let me tell you what happened. So if I do this process, okay, and then I try to integrate from 0 to 2 pi as last time. Remember when we integrate 0 to 2 pi on this helix, what happened? We get something longer than 2 pi, right? Remember last time we said that the what do you call that? Rubber band, right? So if you take a rubber band, okay, you snap it, and then you make it go around the helix, and then come back to the same point. Actually, you need to stretch the rubber band a bit. Otherwise, it cannot come back to the same exact point. I mean, regardless of the Z component, the height. Okay, so you need to stretch a bit. So last time we found that it's actually 2 pi square root 2. Okay, but if we reparameterize this curve, okay, for example, we get this new reparameterized curve here. If we integrate from 0 to 2 pi again, okay, we will get exactly 2 pi, which is the circumference of the unit circle. That means we stretch in the time direction already to make a unit circle. Or in another word, the length we computed using this curve is actually 1. Okay. So what we're really computing is the x component. Okay. So the key point of this reparameterization is what you integrate over is just 1. Okay. After you reparameterize, you will get 1 inside this integral. That's the point. Okay. So how to do reparameterization? You need to follow last week. I mean, Tuesday. Okay. So this is called the arc length parameterization. So it gives a curve parameterized in terms of arc length that is traced at a unique speed. Okay, the speed is a unique speed. So if you compute the length of the velocity, which is speed, it is 1. So this is the point of the arc length reparameterization. Okay, I think we have you should seen this before, but we just repeat it again. So last time we stopped at this Newton's second law of motion. I can go into problem. So I already post out the solution. So you start with a space curve position, right? Space curve equation. And then you find the velocity. How to find the velocity? So let us draw some diagram. Let's draw some diagram. Okay, so let's read the question again. An object with mass m move in a circular path. Okay. So a mass object with mass m, okay, move in a circular path. with a constant angular speed, omega, that has a position vector as follow: a cos omega t, a sine omega t. So position vector, right? So where does the position vector start from? Anywhere. Anywhere? No. Of course, I mean, yeah, for position vector, it doesn't start anywhere. Although you can move the vector freely. So whenever we talk about position, right, we need to have a reference point. Okay. Remember, you always call the position vector as or P, or M, or N, or Q, or something, or something. Remember? So or is the, what's or? Huh? Origin. Okay, so position vector we always refer starting from the origin. We need to somehow have a reference point first. Okay, so this is our reference point. Hey, where's Sui Long? Sui Long? Gone. Okay. Position vector. Okay. Okay, next. So what's the velocity? Okay. Velocity is displacement. First derivative of your displacement. Okay. Also, velocity is the tangent line. Okay, it's the tangent. Okay, they are both refer to the same thing but different interpretation. Okay. So let me put down, so displacement is RT. Okay, so what's velocity? So let's call velocity VT. VT is equal to, is defined by R prime T. Okay, so you got the velocity. Yeah. Okay. Anyone still remember why this this tangent line is 90° to the position vector? Anyone still remember why? Just a test. Anyone still remember why the tangent line here is 90° to the position vector? Huh? What? No resultant force. No, it's the thing that we prove in class. You want to say something? In class. We prove that the if the if the length of the vector is constant always, then R prime T is perpendicular to RT. Remember, we use the dot product stuff, and then we differentiate, and then we show that it's 0. Remember? Yeah, you can recall it. Okay, so what about acceleration? So what's the definition of acceleration? So acceleration is the first derivative of Vt, which is the second derivative of your displacement. Okay, so I believe you have seen this at some point, but in a one direction, right? Real direction. But now we do it for 3D. So if you collect all these tangent line, okay, so if you collect all these tangent line, they trace out another graph, okay, and then you take the derivative of that graph again. right? So the idea, you see the idea. So first you have this position vector. Okay, let's repeat this process. So we have this position vector. Wait, hello. Too excited already. We have this position vector. Okay, we take out, so we trace a curve, circular path. Okay, and then we compute the tangent, which is the velocity. And then you also can join this point together and compute the tangent again, which is the acceleration. And you can still continue and do repeat and go on and go on. But not sure what are those mean, what those quantity means yet. Okay. So you can just repeat the process and then. So this is the this is exactly the special part of maths. Okay. So for maths, you can keep going on and then keep going on and do. Just repeat the process, but you don't know what is going on. So physics will turn these maths into quantity, physical quantity. Okay, yeah. So physics needs maths to describe the physical quantity. But maths can extend infinitely creatively. Okay. Okay, so I don't want to do the calculation. We just go through what's the answer. So we have this displacement, okay? And then displacement, how to get velocity, we just differentiate. Okay, so how to differentiate a vector function? You differentiate component by component. Okay, so you differentiate component by component. And then if you want to compute acceleration, you need to differentiate your velocity. Okay, how to differentiate a vector function? You differentiate component by component. Okay, so if once you did that, you see a very weird thing. So there's a minus sign coming up from the acceleration. Okay, so meaning you accelerate in a negative direction. Okay, so also in this question here, they ask you to find the force. So the force is equal to ma. This is Newton's second law. Newton's first law is inertia, right? Newton's third law is reaction. So if you hit your friend will hit you back. So this is Newton's third law. Okay. Yeah, so first law is if you move, you're forever moving if there's no external force. If you stop. Okay, so what does this negative mean? So the physical meaning of this negative is the force, okay, actually add to the in the opposite to the position vector. Okay, so if you try and spin around a center, okay, you will feel that there's something keep pulling you in to the center. Yeah, you can try yourself. Okay, you experience something, seems like there's something pulling you in if you try to spin around some center. So this is how exactly the satellite planet works. They call it a centripetal force. Okay, so mathematics is to make physics precise. Okay, so when in the real life you feel some how to say, okay, I'm not sure. So in your life, right, sometimes you will have a gut feeling. Okay, when you meet some phenomenon, you have a gut feeling. So meaning you always will feel that feeling. So why will you always feel that feeling? Right. So actually, sometimes, I mean not sometimes. At least my hope is to describe everything, can be described by maths. Okay, never mind. Okay. Okay, next. What's time? What's the time? So maybe let's discuss this question and then we will take a break. And then we will start new stuff. So let's finish this one last question as a tutorial. A projectile is shot from the origin at an angle alpha from the positive x-axis with an initial velocity v0. Assuming that air resistance is negligible and the only external force is due to gravity, find the position function RT of the projectile. And then another question is, what value of alpha maximizes the range? Okay, so how to start? Huh? How to start? How to start? Any idea how to start? Find the acceleration, sure. Okay, so let's find the acceleration. So what's the acceleration here? 9.8. Good. Let me put down AT equals to 9.8. In what direction? Huh? Okay. Up. Okay. Downward, huh? Outward, then we don't need aeroplane anymore. Okay. So downward. Okay. We need downward, but we need to fix one reference point first, right? So what's the reference axis? 0. So which axis we want to fix? Okay. First of all, this is in R2 or R3? R2, right? Okay. So we got IJ, right? Wait. Too excited already. Acceleration in J direction or Y direction? Sorry, J or I? J is going up, right? So you want to downward, so you put negative. Okay. Maybe let's keep with algebra easier. Or let's keep with the G. So what do you want? You want position function. Okay. Now you got acceleration, right? How you go from acceleration to position? Displacement, I mean. Integrate. Good. Okay. So, but you need to integrate twice, right? Okay, so you will pass by velocity first. So you want to compute velocity first. So what do you get? So how to integrate a vector function? You integrate component by component. Okay. So first part, what do you get? What do you get for I? What do you get for J? Some constant, right? Some constant. Because this is really 0 I minus G J. What do you mean? What? Wait. So okay. See. Constant I differentiate, you get 0. So how about J part? What do you get for J part? You integrate minus G. What do you get? Yeah, maybe I just write down minus G dt. Okay, in case you so like this. Okay, so how to integrate minus G dt? Dt, right? Minus gt plus another constant. Okay. G is a constant, so it's not involving time. So you just think of it as another number. Integrating 1, integrating 2, integrating 3. Okay. So you get GT. So this is the velocity. So we still want to get the displacement of the position vector, right? So we need to integrate again. Going to integrate again. So what do you get? You get C1T, C1T, I plus minus G E squared. Need to divide by 2 now. Okay, divide C2, C2, E. I think you need to add some more constant, right? Yep. Mm. Let me see again. So what do you say? Velocity is the final. Okay. I mean, you mean how should I put it? So V final minus V initial, over time equals to A. This is what I mean. I think you can do this, right? Let me think. I think we can do this as well. I think we can do this. Yeah. Yeah, I can do this. Wait, let me think. Uh, this means that this velocity is linear, isn't it? Linear, right? Linear. But now I think that one's for linear. Okay, so how to determine this constant? Okay, any information given or not? So this constant will be determined by initial value. Initial value problem. So what are we given? Okay, we start with initial velocity v0. When time is equal to 0, the velocity is equal to v0. Okay, I think there's one problem here. Reading this question, right, you need to differentiate what are variable, what are number. Okay, so this is the part why maths get a bit difficult here, right? So when they say it has an initial velocity v naught, that means this v naught can be any speed. Okay, we just call it v naught. Okay, if you like, you can take it as a 2 meter per second or 3 meter per second and so on. And then we also fix the gravity at g. Okay, it's 9.8. And then we want to find the position function. So position function is a function that's moving, depend on t. Okay, so at t equals 0, we have this fixed velocity, right? Okay. They just give you a vector, right? How you split this vector into I and j component. How to split this v into I and j component. This is a test on trigonometry. Say again. How to split into S and Y coordinate. Listen. but you are not given the exact form of V0. Right? That it just simply give you a function. I mean vector. So how you turn this vector into IJ form? Parabola equation. Parabola equation. Parabola equation. No. I mean, how you split. Okay. My question is just simple. So, how you split. So, okay, let me turn it to another question. So, how you split a vector into IJ form? Yeah, yeah. Who said it? Yeah, orthogonal decomposition. Okay. So, I mean, they give you a alpha, right? So, they give you alpha. So, how you split the green arrow into the two red arrow? How to split the green arrow into the two red arrow? How about I move this arrow here? Orthogonal decomposition, that's a big word that contains a lot of things. So I want you to simplify to some easier thing. Still cannot see? Cos and sine. Not exactly Pythagoras theorem. Pythagoras theorem is length, right? A square plus C square equals to A square plus B square equals to C square, computing the length. But now we want to decompose the vector. Right? Okay, use the cosine and sine. Right? Okay. Which is what? Which is equal to cosine and sine. Okay, good. So which is equal to, I think we need to compute the length, right? So this is a cos alpha I. Okay, does everyone agree? Agree or not? Agree? Agree? Agree or not? Okay, so from the vector given, we split into I and j. Okay, split into the horizontal component and the vertical component. Okay, and then we try to put it back here. Okay, so what is what? So which is V0 is equal to C1I plus C2J. Okay, so we find that our C1 and C2 is just the horizontal component and the vertical component of the initial velocity. So this one two, that 1 equals to 2. We get that C1 equals to the component of V0, and then C2 is the vertical component of V0. Okay, what's next? So we can further put it in here. Oh, here should be another one. Don't know what it. So let's put this in. So we get four t squared over 2. Yeah. this thing at T. How about C4 and CJ? C4 and CJ, how to determine? Okay, I already tell you how to determine for velocity, right? So you should be able to use the same principle to determine the C4 and C3. So how to determine? What condition you need to look for? Huh? So for velocity, we look for the initial velocity, right? So for position, you need to look for the initial position. Okay, what's the initial position? Huh? Zero, right? Huh? Right, zero. So when R t equals to zero, it start at 0, 0. Okay. So if you start t equals 0, what do you left? C4, I and Cj, C3, J. Right? But these two have to equal to 0. Make sense? Okay, let me write down. So at t equals 0, R0 is just 0. 0 vector. In other words, is 0 times I plus 0 times J. So on the other hand, so let me make this smaller again. Okay, so what's next? Okay, on the other hand, R0 is equal to C4I plus C3J. Okay, so this gives us C4 equals 0, C3 equals 0. Okay, so all together we get RE equals to the speed of this naught times cos alpha t at I, and then plus minus gt squared over 2 plus the vertical component of the initial speed times t j. Okay. So what does this mean? So let's look at what does this mean here. So we stop at here. So this describes the displacement of your object, right? So horizontal component, you see, horizontal component, it is just determined by the initial speed. Okay, so no matter how you throw your object, okay, you play ball, right? You play ball, right? All of you play balls, some form of balls, badminton, uh, volleyball, and so on, right? So the horizontal component is decided when you throw, okay? But the vertical part will be affected by your gravity. Okay? If there's no gravity, then your ball will just keep going. Okay? It's because of the negative here. You see the negative? Okay, so the gravity pull your ball down. Okay. Makes sense? Makes sense, right? Okay. So you split your velocity to horizontal, vertical, and then the vertical part get controlled by the gravity. Since you guys quite tired, need to do the next part. Let me see. Next part is how, let me see first. Let me see first what you need to do. What value of A maximize the range? uh, Do you want to continue or you want to take a break? Take a break. Ah, okay. Finish this first. Okay, finish this first. Okay, finish this first and then we take a break. Okay. Yeah. Question? Wait, what? You want to see this? Okay. Okay, so think about what value of A maximizes the range of D. So you need to find an angle such that you throw the furthest D. What condition you have? What condition you have? dy dx equals 0. Okay, I think you can solve it that way, but you can see that what we have now is we have x in terms of t, y in terms of t. So you can combine these two together such that you have y in terms of t, y in terms of x. I think you can do that. You can go back and try it. Yeah. You can try and write y in terms of x and then do dy dx. What do you mean? Oh, you mean use the okay, so yeah, I think I get what you mean. So that's the formula, is it? dy dx equals to dy dt over ds dt. Do we want to try this? Let's try this. Huh? What? See if this will get into trouble or not. Okay, so I think it's quick, quite fast. So let's do it. So v naught sine alpha minus gt over ds dt is v naught cos alpha. Okay, so you want to solve this at 0 and then find what's the t, right? Find t. Yeah, find t. Yeah, find t. Okay, let's find t. So let me think. So it's maximum when dy dx equals 0. Okay, when dy dx equals 0, there's few condition will happen, right? Either it's maximum, either is minimum. So let's pick what is dy dx. So when okay, let's just keep going. I also don't know what happened. Let's try. They show different method, so maybe we can try this. I don't know which one is faster. So let's do it. Yeah. So when dy dx equals 0, what do we get? We get v naught sine alpha minus gt is equal to 0. So t is equal to v dot sine alpha over g. Okay, so at this time, you will meet maximum or minimum. So if you want to check whether it's maximum or minimum or not, maybe you need to go to second derivative, right? Whoa. Ah. I think we can do it, but just do do okay, do. Okay. Last time, what did we say about this second derivative? It's a dy over dt d huh? d dt huh? This one correct. Inside dy dx. Okay, correct. Okay, this one made more sense. Okay. So compute this. Is it crazy or not? I think not. Okay, let's do it. So the numerator is what? Numerator you left with minus g over v naught cos alpha. Dx over dt is v naught cos alpha, which is equal to minus g over v naught cos alpha squared. Okay, very good. This one has nothing in t. Nothing in t, nothing in x, right? I mean, this one is a constant function of constant function. So constant, negative, constant, man. So you always get maximum. Yeah. Because this is the constant negative, man, right? So I think this is good. So we got this t as a maximum. So what's the question again? We want to find the angle. We want to find the angle. We want to find the angle. So that means we need to plug this t into our x and y. Okay. d2y ds squared, which is always if maximum happen t equals to v naught sine alpha g. Okay, so let's check where is this point here. Can we find alpha actually? So for okay, let's do this. So for t equals to v0 sine alpha g, what is x? X is equal to v naught cos alpha v naught sine alpha g, and then y is what? Y is something. Y is v naught sine alpha times v naught sine alpha g minus half times g v naught sine alpha over g squared. Okay, so maybe you can simplify this. So v naught square sine alpha square over g equals to, sorry, minus 1/2 v naught square sine alpha over g. We can cancel. So it's a good sign. So if things can simplify, normally it's a good sign. If too simplified, then maybe you have trouble. Okay, so we got these two, x and y. How to find alpha? How to find alpha? Okay, so I think we haven't, did we done yet? We done yet? So we say that dy ds is 0, but I think there's a condition, right? There's a condition. Because when you reach the ground, right? When you reach the ground, y have to be 0. Okay, so this have an extra condition. So we have extra condition actually. Okay. Maximum range point f y equals 0. So when is it y equals 0? So when y equals 0 or v naught square sine alpha square equal to 0. Okay, so if v naught is not 0, then you have to opt for sine alpha to be 0. So when is how sine alpha to be 0? Sine function, when is it 0? 0, pi, 2 pi, and so on. So it's the n pi. Yeah, at n pi. So alpha equal to n pi for all n 0. N have to be in natural number. Or I say for all n greater equal to. Okay. Then here come to a problem, right? So the problem is when x equals to v0 cos sine pi over g is maximum. Okay, so when this point is a maximum point, okay, picking from alpha goes to n pi. Cos and sine is like fighting. So can you combine cos and sine together? Trigo identity again. Sine 2x, is it? Huh? Over 2 or 2x or what? Over 2. Okay, let me write down the trigo identity first. So trigo identity. So what's the identity you want to use? Sine 2x equals to what? 2, 2 cos alpha sine alpha. Is it? Okay. So let's use this. So using identity above, x is equals to half b naught square sine 2 alpha. So here become xx first. G. Okay. So when is this maximum? Maximum when sine equal to 1. Okay. So d x is maximum when sine 2 alpha equals to 1. Okay. So when is it sine equals to 1? Cover. Huh? Cover 2. Okay. So that alpha equal to pi over 2. Pi is equal to pi over 4. Anything wrong or not? So what's the actually it's I Huh? Is it? Okay. Okay. We stop here first. Yeah. We stop here first. Take a break. Okay, 9:26 we come back. 9:26. 26, 26. 26, 26, 26, 9:26 we come back. Okay.
所以叫你刚刚发现，哎呦，
我要，
什么？
就是我刚刚说的这个，我觉得是可以用的。
这个可以用，你用一用。
我用了，答案跟这个是一样。
一样。等一下。
因为这个是相当于是1为上的，但是我们现在知道这个 A 向量它的那个就是方向坐标，所以说相当于是它可以分解成一个这个和一个这个。所以说如果
所以你说 V 全部 V 跟 V 那都分类。对。
对，就相当于
OK
它加过来，其实本来就是
OK
在2个方向上的
我
那个分。
觉得可以，我觉得可以，我觉得可以。但是你在用这个的时候，其实我们就是在 integrate，其实我们就是在证明这个东西。我们的定义是因为他们的定义用这个定义吗？他们定义对吗？高中的时候定义 A 是这个东西，但是我们的定义是我们要 integrate 那个 prime，对。然后如果你做我们这个定义，你就会拿到这个定义。
我也可以用这个方法做。
所以如果你用这个方法，就意思说你没有用我们的定义。啊，所以如果你要用这个，你要先证明说我们的定义可以跑这里先。
哦，所以为了采分的话，我还是尽量用这个。原始的是。
对，除非我们说我们已经证明了，从我们的定义可以去到这里，然后以后就可以。
哦，然后还有，哎，你是这么写的，那我到底是在课堂上我
一样的，其实比较好是两个杠的，说我懒惰，其实是一样的，I mean 两个杠比较好，两个杠比较 general，比较好。我签到表在哪？我还没有发，我没发。哦，好的，吓死我，我还没带了，还没发。你要签先，好吧，你就传一传。哦，喂，我先不要传给我要讲一件事情。等一下我传给你们。啊。干嘛我说 DYDX？因为他要找 maximum 哦。啊，是的。
那 DYDX 等于零的时候是这个 point 的。
你是想我会找到这个点是吗？
嗯，
感觉也是对的。
通常来我们是
我觉得好像有问题哦，这个东西，因为我这个 Y 跟这个 X 都对不上了。
讲用 DYDX
对，
一个 maximum length 嘛，还给你对。那么 DYDX 不是应该好像是对 X component 吗？如果你
对哦，我也是觉得，刚才算的怪怪的，我觉得这个错的这个，你看这两个东西都对不上了。
对啊，
还是对哦，然后更奇怪啊，这个答案是也是这个 alpha，就是更奇怪，我就觉得很奇怪。然后我现在是在想什么东西？对，你好像讲的是对的。其实我在找，
这都没有用到你对呀。
对呀，我就是说，我就想奇怪，怎么没有用到了？然后就是很奇怪，怎么会对到答案哦？是因为刚好找出来的那个 x 是一模一样的 equation 来的，就是也是这个。如果真的去找那个 dt 的，刚好也是这个东西，
这样讲你说那个，
所以这是错的，其实都对不上了。我刚才在想，我还没有想到理由怎么讲，然后刚才幸好你过来跟我讲，我觉得奇怪啊，这对不上了。
所以我问你刚刚
对，
讲那个 parametric curve 那个，
啊，
那么 integrate 会是对，它不是用 parametric from 那个 t 吗？
再说一次。
因为你要算alpha 怎么样？
那它这个那个 curve 就是 from 那个 original，
是，
这样那个 original curve 如果 integrate 出 square root 2的话，这样就这个
哦，因为，等一下，你再说一次。你讲本来是 square root 2，然后忽然间是一哈。
因为就是之前学的 parametric curve 是跟之前的 curve 是一样的，就是用同个 variable 来算嘛。
然后对，
可是这样的话，如果我们是一样的话，就
啥？OK，我知道了。因为你看啊，我们之前是从零到 two 拍，不是？通常我们变了 variable，我们通常也会变这个东西的。现在我不变它，因为如果你看变 variable 的话，我本来是零到 two 拍嘛，现在的话应该是我要从零到 two 拍 over 2 over square root 2，对不对？这样你就会算出我们昨天算的东西啊，two 拍 square root 2。但是我还是 integrate from 零到 two 拍。 你懂什么意思吗？啊，因为我的这个 integration 左边没有变，但如果你说我变了 variable，我也变我的那个，这样我又算回以前的了。它的这个 point 是说，如果我在它的时间那边伸或缩了过后，我就可以把它算成一个 unit length unit speed。
那如果我等大约可是
就是 based on unit speed 吧。你的 speed 是1，因为你看这个是 length of 一个 velocity 嘛，所以它是 speed unit speed。所以意思是说，不管你多长，你 integrate 你就是那个长度啊，管你那个 curve 怎么d r d alpha 比较，给我想一下 d r d alpha。
dx 的不是应该是那个 x 功能，你要 maximize。
是啊，要花1个小时坐在这个事情上面。对啊，x 就是 r。
不一定啊，你 r 可以分手瓜子，
有，它应该字体好像是跟的。
有海跟。
可能这题都不需要到 first derivative 去解哈。
对，
啊，应该不需要到这种东西。
现在那个
是吗？
两者
现在只有一个很简单的 condition 吧，就是只要设定它 y 等于0就是这样。然后要讲 prove 它 maximum 的话，这里没有哎。哦，这里有，I mean，它的等于2个 point 嘛，它就 set 它的 y 等于0嘛，
呢？
哦，你就 test 拿什么 t 的时候它是最长哦。
怎样讲？怎样找？
因为你 set 这个 y 等于0了嘛，你不是可以找 t，你就知道什么时间它已经跌在地板了，然后你就 test 这2个时间，看下哪一个时间会给你最长的 x 哦，它就 maximize 哦，懂吗？OK，一个条件，这个条件 maximize 的意思是它要掉到地板上，对，
就你慢慢一个一个探索。
没有，你看这个只是一个 polynomial 吧，polynomial 就有2个答案吧，最多，所以就这2个答案，你 set 这个 y 等于0，有这2个答案，然后这2个答案你就放回来这边 test 啊。
一个 alpha 一个 t，你只要 remove 掉这个。
哦，I mean，你的 t in term of alpha，然后你再放回这边，那你再找哪一个 alpha 是最长的？就回到我们这个方式，等下有 t 了，那有 t 了过后不是有 t 了过后放进来看一下什么 alpha 最长。
我知道那个会对，是因为来，
因为刚刚好最后这一段是一样的东西才会，Yeah，
可是你都不需要做这个。
那个
来找一个没有 t 的，就来没有 t 的 equation 嘛，就 divide dx，你 set divide dx 等于0，来找一个 equation 在上面。
是吗？
这才是，哎，好像也不会没有，这样也很奇怪哦。这个的话，
这个来，这个 这个你这个通常是用来 maximum 的，right？
对，
就大过0的时候是什么，小过0的时候什么来 test 吗？没有用这个，你就用那个 equation 吧，所以你会推。你用的是来，你过后用的是，你要找来sin 2a 等于1。
但是问题是我也 reach 到这一步嘛，刚刚好这一步有一点差距啊，其实出了一个1/2，但是它的点还是这边 reach 到 maximum，但是
X 吧。
哦，
哦，我知道了，我知道了，我知道了，真的，我们应该是在算这个点，刚才我们在算的是这个点，对，然后刚好这个 maximum 跟这个 maximum 应该
一样，它是一
啊
个圈。
没有，因为一定要一样嘛，一定要一样，因为你丢出去的是整个 projectile 嘛，所以你如果这边要 maximum，它这边肯定它这边也是这个的 maximum 啊，所以这个的 maximum 的话，你也是要最大的 angle 嘛。所以我们只算到这一边罢了，我们只算到这个点。
如果你要
嗯
顶上去，不是最高？
不，我们已经有这个 path 出来了，我们已经有 path，OK，我们 start with 这个 parabola 其实，所以我们已经 start with 一个这样的 curve 了。
even 呢，就是一个 projectile，
就是一个 project。对，所以你是说水控制它的高度还是什么？
这个 projectile 不是一定是要那个 degree 是等于那个才会是这样 projectile，你高点低点都不会是这样子。
I mean，这个 project 它可以是，它可以是这样，可以是这样，对不对？所以你是说我45度到底什么意思啊？如果算到这个点出来，
当然力不是不一样。
等一下，
什么意思啊
这样如果
？OK，
你
现在我不知道一个东西啊，就是我现在算的这个45度跟我这些什么关系？对，因为如果我算 dy/dx 是 maximum 的话，就是这个东西啊嘛，对不对？平的时候，所以对吗？
对，
对。
已经有的课，你要找它的 maximum，就是你要找什么 value 拿到这个 maximum。
对，
它这来，我问你来，你要什么 length 才可以拿到那个 maximum area 这样子，right？这样我已经给了你一个
你给我
curve，
一个 curve，对
那 curve 已经来已经是带了的，你全部全部
好啊
point 到了。
好啊
不过你要找哪一个 point 你会拿到最高的 value。
好啊，
可是
就这个点，
现在我们
就这个点。
一个 alpha 可以改掉它的那个最高点跟那个最低点。
based on 这个来找不是？
OK，等一下，给我再想的，给我想的。
如果你们 based on 这个的话，我放6个度，我马可以这样子。对，就是老师讲的，对，那还是老师你是用中间找咩？
然后我在想清楚我在做梦。OK，I want to pass this attendance list down, okay? But don't sign for your friend. Okay? Don't sign for your friend. Ask your friend to talk to me. Yeah, ask your friend to email me or message me. Okay? Huh? I don't know. I mean, yeah. So, yeah. Hey, I want to black box just now, the calculation just now. I want to see what I'm doing. I don't know what I'm doing. Okay, so because at first we assume that dy dx equals 0, we will find the maximum. But dy dx equals 0 for the maximum is the maximum of that curve. We are not finding maximum of that curve. So I also, there's another weird thing is the answer come out to be the same. So I want to see what's going on in this calculation. Okay. Actually, the original solution is very simple. If you want, you just try out. So there's one condition you need. Don't talk about maximum. Don't talk about maximum x first. Just talk about how to reach this point. Okay. If you want to reach this point, there's one condition you need. It's y equals 0. Okay. You need to meet the ground. Y equals 0. Okay. If you sub y equals 0, because this is a degree 2 polynomial, you will find 2 points. Okay. And then you need to sub the 2 point into your x and then maximize the angle. And then you will see that it turns out to be similar what we finished just now. Yeah, I think this calculation quite interesting. I want to see what's going on actually. And then I'll give you a full answer. If you want, you also can come and discuss with me if you want. Yeah, I want to give a full answer to what we calculated. Yeah. Yeah. So do everyone know what's the issue here? dy dx equal to 0 is where the curve become maximum or minimum. Okay, yeah. And clearly this point is not what we wanted, right? Okay. Okay, I will post out the simple answer to this question, and then I will also give a full account what we did just now. Okay, explain what we did just now. What does that actually mean? Okay. Okay, the first side I see the question, the answer is not right is because I think this y doesn't match up with the x. This is the first problem I see. So that's why I think there's a thing happening here. Okay. Although this come out to be the answer, but yeah. Yeah, I will write an account what's going on. New chapter. Okay, new chapter. Yeah, new chapter. I think we only left with 25, 15 minutes. So for tests, we will end with chapter 13. I guess so try do revision question, chapter question, tutorial question, review question. Okay. Okay. So if you have question, right? So please bring it next week. Next week we can spend some time because we are early of our syllabus. Cannot too long. Okay. Finally, I'm gonna use some lecture note that I have written by me. Okay, I don't know what's going to be the experience for this class. Last class is kind of deadly, quite dry this chapter. It's funny. Can you tell us how fun is it? What? You like to torture yourself, is it? Okay, I like this kind of person. Self-torturing. Huh? Hopefully, maybe. I like to torture myself and torture people. Okay, kidding, just kidding. Okay. Okay, we will like the tone is a bit different now. So we look at infinite sequence and infinite series. So the tone a bit different. So we're looking for something infinite. Okay. So infinite is the theme in calculus. Right. You want to see, if I can see this, I want to zoom in and zoom in and zoom in and zoom in forever zooming in. Okay. So let's talk about discrete stuff first. Okay, before we talk about function and so on. So we start with sequence. I think there's one obvious sequence you should. Very good. Okay, from kindergarten, you learn 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good. So every sequence we should relate back to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So what are these? Okay, because we are university level already, right? We call it a natural number. Okay, why is it natural? Because once you are born, you are taught with 1, 2, 3, 4, 5, 6, 7. It's natural. Okay, so every sequence we need to relate back to 1, 2, 3, 4, 5, 6, 7, 8. So on. So definition. What's a sequence? So a sequence, okay, we can label it as A1, A2, A3, A4, and so on. Okay, is a list of number written in a definite form. So meaning you got number attached to A1, A2, A3, and so on. And we have some notation for it. We'll write it as compactly AN, okay, n from 1 to infinity, or just AN. Okay. Also, we'll write AN is the n term. Okay, so what are these going on? So what are these? So let's give an example. Okay, so for example, we have 1, 4, 7, 10, 13. Okay, can you guess what's next? 16. Okay, so meaning we set this as A1, A2, A3, A4, A5, and then keep going. Okay, so for sequence, right, really, how should you think about it? So now we go a level up, and talk like adult. So we have like a map from a natural number to real number. Okay, so here is real number, here is a natural number. So you got a map between them. AN. Okay, so in your mind, when you see 1, 4, 7, 10, 13, 16, in your mind, you already place them as first term is 1, second term is 4, third term is 7, fourth term is 10. Okay, so in your mind, you already have 1, 2, 3, 4, 5, 6 in your mind. Okay, so this is what we meant by there's a map from natural number to real number. Okay. Okay. What? What? Okay. Okay. So keep continuing. So let's continue. So continue. So let's put this even further. And let's put this even further. So actually, how you guess this number? That's 16. How to guess 16? How you guess? How you guys guess 16? Okay. A2. Oh, you use difference. Ah. Okay, so you use difference. So what you mean is your A1 is 1. Okay. And then A2 minus A1 is 3. Okay. And then A3 minus A2 is also 3. Okay. So you write it as A1 is 1. And then AN plus 1 minus AN is equal to 3 for all n greater or equals to 2. Okay. So this is another way to write this sequence down, which we call the recursive formula. Recursive. Right? Okay, so you define the next term using the previous term. Okay, you need to start with 1 point, which is A1. And then the next term you define using A1. Okay. There's another way to see this sequence. Any idea? There's another way to see this sequence. Any idea? So think again how you, okay, so you think it recursively. Okay, you think it recursively. So there's another way to think about the first sequence, meaning how you guess 16. check first. So n plus 3. N equals to 1 is already 4. So how? So how? Any idea? Huh? Third way to describe the first sequence. I mean, the n plus 3 is close already. So how to adjust it? How to adjust it? How to adjust? How to adjust? So 1, you need to get 1. 2, you need to get 4. 3, you need to get 7. Two n plus 1. Any idea? 2n plus 3. So when n equals to 1, n plus 3. Huh? 3n minus 2. Okay, we try 3n minus 2. So 3 times 1 is 3. 3 minus 1. So 3 times 6 is 2. Maybe works. Let's write it down first. So let's guess 3n equals to 3n minus 2. Okay, I think this works. So for n. Okay, I think this works. Huh? 1 plus 3n. No. First term needs to start with 1. Yeah. If we start with, let's say, if we start with 0, then 10. Okay. So if we start with 0, 10. So if 3, 1 plus. Okay. So there's a point here. Okay. So there are 3 ways to describe your sequence. One, you just list it down. Okay. Second, you can define recursively using the first or second term you have. Third way is you given one n, you give me one an. The formula for your sequence. Okay, these are the 3 ways you can describe a sequence. Okay, so you can see that there are 2 formulas for an. Depend on the index set, your formula might change. Yeah. Okay, that's all I want to say. Any question? Any question? So even though I say like this, right? So in the example or question, right, you should be able to start with any of them and then. Okay, sorry. You should be able to, given one formula, you should be able to work out the sequence. Okay. It might not be the case that every sequence have this description. Yeah. Okay. Any question? Any question? No? Okay. Okay, continue. Continue. Okay, let's do some more example. So let's find the first, second, third, fourth term of following sequence. Okay, so for example, let's look at an equals to 1 minus 1 over n. Okay, I want you to work this out. So you try. So for A, B, and C. Okay, so try find the first 4 term of this sequence. Okay. Oh, wow. Going to disappear again. So anyone found what is A1, A2, A3, A4? 0, 1/2, 2/3, 3/4. How do you find it? You just substitute the n equals to 1, 2, 3, 4. Everyone following? Okay. How about B? 0, 3/2, 2/3, 5/4. Okay. So in this case, you start with n equals to 3, n equals to 4, n equals to 5, n equals to 6. Okay. Wrong question. Sorry, wrong question. Where is it? Okay, so it's a minus 2/3, 5/4, minus 4/5, 7/6. Yeah, because you guys follow the I also follow the slide. So yeah, I skipped that question because I see that it's similar to A. Okay. What else? Yeah. Okay. So how about C? Same. Okay, this is a constant sequence. So you met constant function and then constant sequence. Right? Constant sequence. Okay, constant sequence play quite an important role, so you should keep in mind. Okay, before we end the class. Not yet. Sorry, not yet. I think we stop at Fibonacci sequence later. Okay, we stop at Fibonacci sequence. Okay, let's start at Fibonacci sequence. So find a recursive formula for Fibonacci sequence. Anyone heard about Fibonacci sequence before? Yeah. Okay. So can you write down a recursive formula for this? What's the recursive formula for this? Can anyone see any pattern here? Yeah. Yeah. So you plus the previous two terms, you get the sum for the next term. Okay, so how do you write it down? How do you write down? N minus 1 plus n minus 2. Okay, but there's a problem here. Okay, so when n equals to 3, This is A2 plus A1. So what is A2 plus A1? What is A2? What is A1? How you know? No. You need to define. You need to define. Okay, so you need to start from somewhere. So you need, in this case, you need to start from two places. A2 equals to 1, A1 equals to 1. If you just define A1 equals to 1, you cannot find A2 using this formula. Okay, so you need to start from two places. So you need to start from A1 equals to 1 and A2 equals to 1. Okay, so this gives the Fibonacci sequence. Before we end, there's another way to write this Fibonacci sequence. Okay, so this is the second way. Let me write it out. wait. Okay. You also can write it in this form. You know what's the thing inside there? That's a golden ratio. Yeah, golden ratio. You know the Mona Lisa. So Mona Lisa got this golden ratio inside the number. Yeah, also got, yeah. So you see, this Fibonacci sequence is related to golden ratio. Okay. What else I would say? Okay, so if you go search online, you can see that those plant, flower, or leaves that satisfy this Fibonacci sequence. Yeah, seashell also. You will see the symmetry that has a golden ratio. Okay, and actually I made this an assignment question to my other class.
What?
Assignment question. Yeah.
For another class.
For another class. Any more question? No more question? I'll try and fix the dy dx equals 0 and then I'll let you know. And then happy holiday. Selamat Hari Raya. Okay. Huh? You know one? Assignment. Please give me back the attendance list. Huh? 要做工。